So this video begins with a question. Identify the solution or solutions. So we have four different items listed: water, ice water, carbonated water, and the air in your room. In order to answer this, I think we need to learn more about what makes something a solution and which of these particular choices would best be described as a solution. Within chapter 1, to get things started, we're looking at ideas involving matter, energy, and then extending that to making measurements of matter. The start of it, classification of matter, is what's going to be involved in this particular video. For each of these points, what I've tried to do is to take the topic and then identify what we need to do with that information. So for classification of matter, we want to be able to apply various terms like mixture, molecule, compound, solution, etc. In different ways using different representations. So classification of matter. Matter is the physical material that makes up the universe. If something has mass, occupies space, it's matter. You're probably familiar with atoms as the smallest building blocks of matter. When we're looking at the properties of matter, we're going to find that it depends on the type of matter that is present, the atoms that are present, the composition, and then also how those are arranged, the structure. Properties depend both on how the atoms are arranged and which atoms are there in the first place. Now, this seems like a pretty broad description. If matter is a substance that has mass and occupies space, we're going to call it matter. So one might ask, well, is everything matter? That seems pretty all-encompassing. An emotion like hope is not matter. Love is not matter. Whatever emotions are being depicted here is not matter. So I'm just pointing out that within this class, it's a physical science class. We're going to be looking at matter and how matter interacts with other particles of matter, how energy is involved, but we're not interested in accompanying emotions that go with that. When I mention atoms, you probably are familiar with the periodic table that lists these building blocks. To start out here, I want us to know the symbol and the name for the first 30 elements in the periodic table, along with a few common other ones. And those other common ones I list right here. So in this image, I'd like you to be familiar with all of these elements. And when I say familiar, let's know the name and the symbol. You don't necessarily have to know at this point where they're found on the periodic table, but you might. But let's make sure that we can go back and forth between the name and the symbol. So if I mention Li, you'd be able to understand that to be lithium. If I mention carbon, you'd understand the symbol to be C. So let's see what terms that we can have now if we're just using them to describe matter. First one is the idea of a pure substance. Pure substance is matter with distinct properties that's the same in any sample that you pick up. So if we're talking about gold, if you're in India, if you're in South Carolina, if you're in Columbus, Ohio, gold is gold. If your sample of gold is different than mine, well, we're not looking at the same substance. If it's a pure substance, it's always the same no matter where we find it. Gold is always gold. Sodium chloride is always sodium chloride. That's the description for a pure substance. States of matter, we'll be discussing matter as solid, liquid, and gas. You might be familiar with other states of matter like plasma. Those are interesting, but we're going to have plenty to talk about if we just stick in this class with solid, liquids, and gases. You've probably heard both elements and atoms. The ones I want to draw your attention to that we want to be careful with, first of all, is a molecule. So a molecule is when we have two or more atoms held together by chemical bonds. They're tightly held together. A compound would be two or more different atoms that are held together by bonds. So let's make sure that we know the distinction between a molecule and a compound. A mixture would be two or more different substances that are just mixed together. They're not chemically combined. So they might be in the same container, they might be distributed within that, but they're not held together by chemical bonds. Here's an image from your textbook showing the frigid North Atlantic. So I list here on the left the different terms that I've just introduced. A pure substance, different states of matter, elements, atoms, molecule, compound, and mixtures. I think that we can use all of those to describe what's going on in this image on the right-hand side. I think in 1 or 2 sentences, we could include a description that has all of these particular words. One other thing I want to draw your attention to is at the bottom, it's showing particle level representations of H2O as a gas, H2O as a liquid, and H2O as a solid, as the iceberg there. These particle representations are going to be an important part of this class, so we want to be able to interpret what's going on there. So your task, what I'd like you to do is in 1 or 2 sentences, see if you can use all of these terms describing what's going on within the picture. Now, mentioning mixtures, we can classify those as being either homogeneous or heterogeneous. So in this image right here, we have 2 different colors of sand. When we mix them together, we can see that we can have it where we see these distinct regions of each. This would be a heterogeneous distribution. It's inhomogeneous. I see different pockets, different regions that are going on. If you took the whole thing and mixed it all together, scrambled it all together so you didn't have these distinct regions, that would be described as homogeneous. When you go to Chipotle and you get a burrito bowl, it usually comes like you see at the left. If you take it then, and maybe you don't want to eat it that way, so you take your fork and you mix it up to distribute all the luscious ingredients there, you can see that you have a different arrangement. So which burrito bowl would be more homogeneous? That one looks more homogeneous. It's more mixed all together. What I'd like you to do is take a moment, think about the world around us. Most of our world is mixtures. It's not pure substances. So there's examples in the world around us of homogeneous mixtures, and there's also examples of inhomogeneous or heterogeneous mixtures. Take a second, see if you can identify a couple from the world around you. What are examples of homogeneous mixtures and inhomogeneous? Returning now to our original question. So we have water, ice water, carbonated water, and the air in the room that you're in. The task is to identify the solutions. A solution is a homogeneous mixture. Let me add another piece of information. If I'm trying to represent water, I'd be representing it as the H2O molecule, and the L is given the state. So that would be H2O as a liquid. The air in your room, I'm sure the air in your room is primarily oxygen gas and nitrogen gas. So what I'd like you to do is see if you can add this kind of chemical description, this kind of chemical formula. What do you think ice water would be represented as? How about carbonated water? And how about the air in your room? And with that information, see if you can identify which one or ones are solutions, are homogeneous mixtures. The questions and topics within this video are from the start of Chapter 1. Here's some suggested end of chapter problems on this topic. So question 1.1 is asking you to apply these same terms for different particle representations. It's pointing out that if you want more information, look in section 1.2 of your textbook. And the second one is on this idea of classifying something as a pure substance or a mixture, and then considering whether it's homogeneous or heterogeneous. Be helpful to give those both a try.